Hi guys, welcome to lesson 9.5, completing the square. So our main focus today is to be looking for what we call a perfect square trinomial. So to give you just an example of what that looks like, what we're going to be seeing today is this right here is what we call a quadratic trinomial. Throwback to our last topic, we learned how to name these different equations, and trinomial just means that there's three terms, and quadratic comes from our exponent of 2. Anyways, we're just going to be trying to put together today a quadratic trinomial that allows us to factor in this way. Now, what is special about a perfect square trinomial is that when we go searching for the two numbers that multiply to c and add to b, it's always going to be the same number. So think about how we would do that here. What are the two numbers that multiply to 9 and add to 6? Those two numbers are 3 and 3. When those two factors, we call them binomial factors, when they are identical like they are here, we can rewrite those like this. That just means we have two x plus 3 factors. That's going to be our goal in every single question today, to come up with a perfect square trinomial. In most of these questions, guys, we're going to have to find the right c value that allows us to do that process. Let's take a look at how that would work in these first questions down here. We're actually going to skip the first part of example 1 and jump right into this question here. It says, what value of c completes the square? First thing I want you to write down is what our goal is. This is our goal in all of lesson 9.5. We want to get a perfect square trinomial. We want to find the c value that allows us to factor in such a way that we can write our answer like this: x plus some number squared. If we're going to find that perfect number, this is the equation we use every single time. We are going to find the c value by taking the b value, dividing it by 2, and then squaring it. Let's take a look at how that's going to work in part A. All right, first thing we're going to do is just identify what the b value is. The b value is 12. So what we're going to do is we're going to take the b value, we're going to divide it by 2, and we are going to square it. Every single time we do that, that tells us exactly what that c value needs to be. All right, so 12 divided by 2 is 6, and then 6 squared equals 36. So 36 must be our missing c value that we need to make a perfect square trinomial. Now, here's how we can check this. We should be able to now factor this in such a way where, of course, x will always come first, but these two numbers right here, the two numbers that multiply to c and add to b, those should be the exact same number. So just think about that for a sec. What two numbers multiply to 36 and add to 12? The answer is positive 6. And again, for this to be a perfect square trinomial, these will always be the same. Always be the same. So for this question, we were actually done when we found 36. That was the c value that we needed. This step right here is a bonus. That's going to be what we do in the next example, example 2. Let's go ahead and just try one more, though, on how we can find that c value to make our perfect square trinomial. First step, again, we just identify the b value, and it is positive 8. So to find the c value, we're going to do b divided by 2 squared every single time. When we do that, we get 4 squared, which is 16. 16 is our missing c value. Let's go ahead and plug that in. And to make sure that this is the correct c value, just like before, we should be able to factor this in such a way that these two values right here, the two numbers that multiply to c and add to b, they should be the exact same number. And that is 4 and 4. Positive 4 multiplies to 16 and adds to 8. All right, let's see how we can now use this more in example 2. So in example 2, the question is, how can we solve the solutions of this equation right here? So the difference in example 2 is now we're set equal to 0, and we still have this perfect square trinomial, and this time we don't have the c value missing. Last time we had to find it. This time they gave it to us. So let's just try it. Are there two numbers that multiply to 16 and add to negative 14? They should be the exact same number, and the only combo that would work would be 4. 4 and 4 we know multiply to positive 16, but they do not add to negative 14. So here's the issue right off the bat. This equation right here, we call this not factorable. So I want you to make this little note to yourself right now. We're going to do this process that we do in example 2. We're going to only do this when we can't factor right away, where we can't do this process right off the bat. Essentially what this process is going to do is we have to get rid of this C value. We want to get rid of it, and we want to come up with our own C value, like we did above, to make this into a perfect square trinomial. Let's go ahead and let's try it. So the first step, it says to write the equation in this form. Now, what that actually means is we want to get rid of the C value. So we're going to subtract it away. We want to subtract it and get it on the other side of the equation. And when we do that, we still have the x squared minus 14x. We still have that on the left-hand side, but we are just going to move that negative 16 over to the other side. All right, step 2 now says to complete the square. And what that means, you guys, is that we need to find a C value, just like we did in example 1. We need to find a C value that will make this a perfect square trinomial. But here's the kick. If I'm going to add in a new C value over on the left-hand side, I can't just add it to one side of the equation. We're going to have to add it to both sides. So I like to call this adding in a blank on each side. We need to add a blank number or a blank space on each side, and we have to figure out what that magic number is. All right, so to find that missing C value, we're going to do exactly what we did before. C is always the B value divided by 2 squared. So B is negative 14. We're going to divide that by 2 and square it. When we do, we get negative 7 squared, and a negative times a negative is always a positive. So that is the magic number. That is our magic number that we need to have in order to get a perfect square trinomial on the left-hand side. The issue is though, when I add that number in, we have to always add it to the other side of the equation as well. So this left-hand side of the equation, that is like the meat of this problem. That is the most important part. On the left-hand side, you guys, we now have a perfect square trinomial. What two numbers, they should be identical numbers, multiply to 49 and add to negative 14? That is negative 7 and negative 7. That is a perfect square trinomial. On the left-hand side, we have to do some simplifying. Negative 16 plus 49. Let's see, I'm going to get my calculator out. And looks like we are getting positive 33. All right, guys, here is the whole purpose of completing the square. We saw in our vocab that we can rewrite this. When we have two identical factors, we're going to want to, in this lesson, rewrite those factors like this. That just means we have two factors of x minus 7, and that's going to equal 33. All right, we're going to go ahead and solve this now. Once we have our binomial squared, we can solve this by taking the square root on both sides. The square root and a little square exponent of 2, those just cancel out. So on the left side, you guys, we are left with, I'm going to bring this over here. On the left side, we're just left with x minus 7. And on the right-hand side, we're left with plus or minus root 33. That's not a perfect square. I can't really simplify that right now. So we're just going to leave it as it is, but make sure that we have a positive and a negative answer. All right, last step here, since we're solving for x, we have to add this 7 over to the other side. And our answer, we're just going to leave it as this expression, plus or minus root 33 plus 7. We could definitely take out our calculator and find out what those exact decimals would be. We would have a positive answer and a negative answer. But for now, you guys, I'm okay with just leaving our answer just like that. If you want to try these next two on your own, go for it. You can pause the video and check your answers when you're done. Otherwise, if you're still feeling a little bit stuck, let's go ahead and do 2 more together. We're going to go through these ones a little bit quicker, but still following these same exact steps. All right, step 1. I try to factor this. I try to look for a perfect square, a identical number that multiplies to C and adds to B, and it is impossible. The only possibilities would have to be 3, but one of them has to be negative in order for it to equal -9. So what we're going to see is we have to do some work. This is what we call not factorable, just like we saw in the first question. So if something is not factorable, we have to get rid of this C value. It's not the C value that we want, so we move it over to the other side. And when we move it over to the other side, we're doing that because we need a different C value. So we're going to add in a blank space on both sides, and we're going to make that C value ourselves. The C value is always the B value, which is 10. We divide it by 2, and then we square it. So 10 divided by 2 is 5, and 5 squared is 25. That is our magic number that we need to add on both sides. And again, the whole purpose of doing that is because now here's our perfect square trinomial. I can rewrite that as x plus 5 times x plus 5. 5 is the magic number. Those multiply to 25, and they also add to 10. Even better, we want to rewrite that like this. This is our entire goal in 9.5, to get to this point right here. All right, so we have our simplified version on the left-hand side. Now let's just go ahead and simplify what we have on the right-hand side, and we're going to bring that down as well. 9 plus 25, and we get 34. All right, so we have completed the square. That right there, coming up with our own C value, we call that completing the square. We can now use that to solve for x. Our first step always is going to be at this point to take a big square root. And when we do, we're left with just x plus 5 on the left-hand side. The square root and the 2 went away. And on the right-hand side, we're always going to have plus or minus every time we take a square root. And 34 is not a perfect square, so we can just leave it like that. And our very last step, you guys, we're going to minus away that 5 because we want to find out what just x equals. And that entire expression is our final answer. Oop, almost forgot my square root. So this right here, guys, we can leave that exactly how it is. Again, in class, we're going to practice finding the decimal versions of this, but this is a perfectly acceptable answer for now. No need to simplify any further. All right, let's do one more. We'll go through this one even just a little bit quicker. Again, when I try to factor this, you guys, there is no 2 identical numbers here that multiply to C and add to B. It's just not going to work. So we have to get rid of this C value. We move it over. And on both sides of my equation, we're going to add in our magic number. The magic C value, I should say, we always take our B value, which is -8. We divide it by 2, and we square it. So let's see, that's going to get us -4 squared, and a negative squared is always a positive. Notice how our C values have always been positive. That will always be true. 16 is our magic number. We have to add that number on both sides of our equation. Let's start by simplifying the left-hand side. Again, we want to go into factor mode. And just to check, the reason we found 16 in the first place was because now there's 2 perfect numbers that multiply to C and add to B. And again, those numbers will be identical every single time. We got that. That is -4. And we're going to go one step further and now rewrite it like this. All right, on the right-hand side, let's go ahead and add those numbers together. 6 plus 16, and we get 22. All right, we found our perfect square trinomial. We can now take a big square root. And when we do on the left-hand side, we're just left with x minus 4. And on the right, plus or minus root 22. Last step, you guessed it, we got to move that 4 over as well. And our final answer is x equals plus or minus 22 plus 4. And I keep forgetting my square root. We want to keep that over the 22 only. All right, you guys, awesome job.